Today we're going to break down one of the most important ideas in all of modern AI, the attention mechanism. This is the core concept that really unlocked the power of models like GPT. So what exactly is it?
Well, let's start with a problem. How does a machine read a long piece of text without forgetting the beginning by the time it gets to the end? For a long time, this was a huge issue. Early models would read a paragraph and, by the final sentence, critical context from the start was just gone. A massive limitation.
The source of this problem was a fundamental design flaw in older models like recurrent neural networks. It created something that engineers call a memory bottleneck.
Think about it like this. Imagine trying to summarize an entire novel in a single short sentence. You lose almost all the detail, right? That's exactly what these older models had to do. They would try to cram the meaning of an entire input into one fixed-sized chunk of data. This information bottleneck meant that crucial details from the beginning just got washed out. But models with attention, they work differently. They have direct access to every single word of the original text whenever they need it.
So by the end of this, you'll understand the incredibly elegant solution that completely solved this problem, a mechanism that now forms the backbone of pretty much all advanced AI.
So what is this big idea? At its heart, it's all about giving the model the ability to use selective focus.
The best analogy is to think of a human translator. A good translator doesn't just read a sentence once, memorize it, and then write the translation. No way! They are constantly glancing back at the original text, focusing on the specific words that are most relevant to the one word they are writing right now.
The attention mechanism gives an AI model that same superpower. For every single word it's about to generate, it can look at the entire input and dynamically decide which parts are important and which parts it can ignore for that specific moment.
And this is the crucial difference. Attention frees the model from that single compressed summary vector. Instead, it gets to create a brand new, custom-tailored context vector for every single output it produces.
Okay, so how does this actually work under the hood? Well, let's get a bit more technical. The most common form of attention is built on a simple recipe that involves three key ingredients: queries, keys, and values.
The easiest way to think about this whole process is like a super fast information retrieval system, kind of like a database. And in this system, every single word in our input gets to play three distinct roles.
First, there's the query. This is the current word asking a question, like what kind of information do I need from the rest of the sentence? Then you have the keys. Every other word has a key, which acts like a label, announcing this is the kind of information I have. And finally, you have the values. If the key is the label on a file, the value is the actual content inside that file. The query looks for the best key, and then it pulls out that key's value.
This all happens in a quick four-step process. First, scoring. The query from our current word is compared to the key of every other word to calculate a similarity score. Second, normalize. Those raw scores are passed through a function called softmax, which just turns them into percentages, or attention weights. This tells the model how much focus to give each word. Third, multiply. Each word's value is multiplied by its attention weight, so important words get their volume turned way up, while irrelevant words get faded way down. And finally, sum. All those weighted values are added together to create one single context vector, perfectly built for the word we're working on.
And that entire process we just walked through, that's called scaled dot product attention. This formula might look a little intimidating, but it's really just the math version of the 4 steps we just described. You can see the queries, keys, values, and the softmax function. That extra bit with the square root is just a small trick to keep the numbers stable during training. This equation is the engine that drives the entire transformer architecture.
So what began as a clever fix for that old memory bottleneck didn't just stay a fix. It very quickly became the foundation for an entirely new kind of AI.
And the timeline shows just how fast it happened. In 2014, attention was just an add-on for older models. Then in 2017, the landmark paper Attention is All You Need was published. Their idea was radical. What if we get rid of the old models completely and build something using only attention? That gave us the transformer. And from there, the floodgates opened, with models like BERT and GPT. Today, attention is everywhere. Not just text, but computer vision and speech recognition too.
And we're not talking about a small improvement here. This was a massive leap. You can see that adding attention to the old models provided a nice boost. But when the transformer came along, using nothing but attention, it created a whole new level of performance, blowing past all the previous methods.
So why should you care about this? Because today,
Well over 90% of the cutting-edge AI models for language are built on the transformer architecture. And if it's a transformer, it's built on attention.
All right, so if you're going to remember just one thing from all of this, let it be this. Attention is the mechanism that gives an AI model a kind of selective memory. It's what allows it to dynamically focus on only the parts of the input that are relevant for the task at hand.
The real breakthrough wasn't about giving the model a bigger memory. It was about giving it a smarter way to use the memory it already had. It's not about remembering more, it's about remembering smarter.